let's talk about properties. The properties are real numbers. There's going to be a few of them to talk about. One in particular, the last one we talk about, is going to be the one that we are going to use, and you will use distributed property throughout the rest of your math career. However far you go in math, you'll be using distributed property. But let's talk about some of the other ones, because you'll have some questions probably in homework on them. The first one is commutative property. With commutative property, we're going to just switch the order. So the order of the numbers. So commutative property of addition would be, if you've got a plus b, that would be b plus a. So an example would be 5 plus 3. The commutative property of that one would be 3 plus 5. Commutative property of multiplication, again, just switch the order. AB would be BA. So if you had 3 times a negative 5, then if you switch the order, that'd be negative 5 times 3. So commutative property, switch the order. So here's rewrite the expression in terms of addition, then apply the commutative property. So we would have 7 minus 5x. So they're really wanting you to say 7 plus a negative 5x. That's rewriting the expression in terms of addition. We did that in the last section. So then if you're going to use commutative property of addition, switch the order, negative 5x plus 7. Here we've got negative w plus negative y squared. If I change that to a positive, change the sign of the second number, then do commutative property. So switch the order, negative y squared plus negative w, like that. Use the commutative property to rewrite. I don't always have to just change the order. Just you could have, if you've got 5a minus 12z, then put the minus 12z in front and put the 5a after that, so plus 5a. X times 14, that would be 14x if you switch the order. So you can see commutative properties, just kind of switching the order around. Alright, so let's see. Associative property, that's the next one. Associative property deals with parentheses, and so the way you're gonna switch in this one, you're gonna switch the parentheses. So the way I remember this one is that associative property has those S's in it. The S's kind of relate to parentheses, so I remember to switch parentheses. If you're having to remember what the different properties are and you don't have the definitions right in front of you. So A plus B, there should be a plus right there. C, that would be then A plus, and then put the B plus C in parentheses. AB in parentheses times C, put the A on the outside and put the BC on the inside. So examples would be like 4 plus 2 plus 8. You would have 4 plus, and then put the 2 plus 8 in parentheses. Because this is all addition, the value does not change at all. Same thing with multiplication. If you had 4 times 2, that's a multiplication, times 8, you could have 4 times 2 times 8, like that. Alright, so we're going to use the associative property. W plus, let's put the 7 plus 8 in its parentheses, and then simplify it if you can. 7 plus 8 is 15, so W plus 15. Negative 3 times 9x, you could do negative 3 times 9. Put those together, and then have an x on the outside. Negative 3 times 9, that would be negative 27x if we simplified it. And then 5/8 times 8/5 y. Let's put the parentheses around the 5/8 times the 8/5. Wonder what's going to happen to those two. They look like reciprocals. And sure enough, they're reciprocals. They cancel each other out and end up with a 1y, or you could just put y. So associative property, remember we're changing parentheses. So negative 27 on this one times a negative 2. We'll put the x on the outside. 27 times 2, that's going to give me 54, and it's going to be positive because I have two negatives, so 54x. This one's going to be interesting. Let's do 2x plus negative 7 plus 4, so I'm going to do the 2x on the outside, and then let's put the negative 7 plus 4 together. So negative 7 plus 4 is going to be negative 3. Now I could do it again. I could put the -3 with the 2, so 2, this 2 and -3, and then the x, and so 2 times -3 is -6x. That one was kind of a roundabout way to do that one. So that was associative property. Identity and inverse properties. Identity property means you either add or multiply and you get the same number back out. So on identity property of addition, if you add 0 to any number, you get that number back out. So 5 plus 0 equals 5. That would be an example. On multiplication property, the identity one, you would multiply by 1, because anytime you multiply by 1, you get the number back out. So 5 times 1 equals 5. So identity means you start with a number, you end up with the same number. With inverse property, you're adding the opposite for addition, so you're going to get a 0. So on inverse property of addition, your goal is to get a 0. On inverse property of multiplication, your goal is to get a 1. So in order to do that, we multiply by the reciprocal. So an example of inverse property of addition would be 5 plus a -5. We're adding opposites. We get a 0. For inverse property of multiplication, an example would be 5 times 1/5. Those would cancel and I would have a 1. So those are your identity properties and your inverse properties. Now here's the property that we use the most. And you're going to use this throughout the rest of algebra. It's called the distributive property. So distributive property, you use distributive property to clear parentheses. And that's how you use distributive property. And what you're doing when you're doing distributive property is you're multiplying the outside times each inside part. So if you've got A times B plus C. See, this is different than associative property because I have a plus sign going on with the multiplication. So distributive property, I'm going to take A times B, and then I have a plus sign in between the B and the C, and then A times C. So the A gets multiplied times the B, and then the A gets multiplied times the C. On this one, they wrote the A at the end, so you can just go backwards. It's the same thing. A times B plus A times C. An example would be 4 times x plus 2. Let's do that one. So that would be 4 times x plus 4 times 2 would be 8. Now, the way that I remember this and the way that I teach my class to remember this is to remember hippity, hoppity, distributive property. And the reason I say hippity hoppity distributive property is, see how I've drawn the arrows each time I've done this? Those are like little bunny hops. And so we do hippity hoppity, and I draw those arrows every time I do distributive property. If you draw the arrows when you do distributive property, it just helps you out. So let's do this next one. We're going to hippity hoppity distributive property. The 3 times the 5w. And I'm going to write this out so you can see exactly what I'm doing. Sometimes you're going to start doing this in your head a lot probably. Then I've got 3 times a 4y, and this is all positive, so I'm writing positives in between. And then a plus 3 times 7, and then you simplify it. So 3 times 5w gives me 15w, plus 3 times 4y gives me 12y, plus 3 times 7 gives me 21. Hippity hoppity distributive property. Okay, let's go to the next page. Let's practice some more. Again, you're going to see a lot of hippity hoppity distributive property. So 2 times 6x, and then 2 times -9. 2 times 6x, and then minus 2 times 9. I just go ahead and put the minus sign. I carry it down in front. So 2 times 6x will give me 12x, minus 2 times 9 is 18. Now this next one's interesting. I just have a negative. Well, if you just have a negative there, there's an imaginary 1 there. So I'm going to take negative 1 times each of these. So negative 1 times 9a minus 1 times a negative 2b minus 1 times a 7c. So that's going to be negative 9a. Negative times a negative makes us a plus 2b. Negative times a positive makes us a negative 7c. And if you'll notice, having a negative in front, all that happens is every sign changed from the original problem. The numbers didn't change because it was a 1. Alright, negative 5 times 2 minus 8x. Negative 5 times 2. And then a negative 5 times a negative 8x. So negative times positive gives me negative 10. Negative times a negative gives me positive, and then 5 times 8 is 40x. And then this next one, negative 8 times negative 4x, negative 3y times 5. So negative 8 times negative 4x. Negative 8 times a negative 3y. And then negative 8 times positive 5. So negative 8 times 4x, that gives me positive 32x. Negative 8 times 3y gives me positive 24y. Negative 8 times a positive 5 gives me negative 40. And so we use distributive property over and over. Can't do enough practice. So 5 times a, 5 times 2. So 5 times a, 5 times a negative 2b. And 5 times a negative 3. And again, I'm writing it all out just so you can see what I'm doing. You may be doing some of this in your head. So 5a, 5 times a negative 2b would be negative 10b. 5 times a negative 3 would be negative 15. Here's one with a negative 1 in front of it again. So negative 1 times a is negative a. Negative 1 times a negative 2b is a plus 2b. So you can see I did that one in my head. I didn't write it all out for you. Okay, let's look at the next page. Click on it. Alright, simplifying expressions. So there was your properties. Now we're going to do some simplifying expressions. We're going to have terms. A term could just be like a 7x. A term could be a 2. It could be a negative 3. It could be a 1/2. Those could be terms. An algebraic expression has terms and coefficients. So if you have a term, 2x squared, the coefficient is the large number. The coefficient of this one would be 2. For like terms, you have the same variable with the same exponent. So like terms would be like 12x and a negative 3x, because they both have an x. Or you could have a 2x squared and a negative 5x squared. Both of those have x squareds. They're like terms. Unlike terms would have different letters or different exponents. So a 2x and a 3x squared. Those are not like terms because one has an x and one has an x squared. So you just have to be careful when you're we're going to be combining like terms is what we're going to do. So when you combine like terms, you need to add or subtract the numbers in front of the variable. And that's if they're alike. So you have to determine that first. So 8x plus 3x, those are like terms. They both have an x. So 8 plus 3 would give me 11x. Here I've got negative 11y plus 8y minus, and there's an imaginary 1 there. Those are all y's, so we can combine all of those. Negative 11 plus 8 would give me negative 3y minus another 1y gives me negative 4y total. Now 6a plus 5, those are not like terms because there's no a with the 5. So that's simplified as much as it'll go. You can't do anything else with 6x plus 5. Okay, so down at the bottom, let's decide. Some of these may be like terms, some of them may not. I have an 8ab, I have a minus 3ab. 8 minus 3 would give me 5ab. Those are like terms. I have a negative 7 and a positive 12. Negative 7 plus 12 gives me plus 5. So you combine what you can combine, and you leave it alone what you have to leave alone. And so I could do the ABs on this one, but I couldn't, and I could do the numbers. But now when I get to 5AB plus 5, that's as far as I can take it. You can't go any further because they're not like terms. So looking at the next one, these are like terms because they both have x to the 4th. So I just add the numbers in front. 3.4 plus 7.1 gives me 10.5 x to the 4th. Do not, here's a side note. Don't change your exponent when we add. We're going to do a whole chapter on exponents and exponent rules. But when we're combining like terms, you do not fool with the exponent at all. You're just combining the numbers in front. Okay, so again, here's some more. Let's decide what's like terms. I have a 5 and I have a minus 2. Those are like terms, and so 5 minus 2 is 3. I have a 1a cubed plus a 6a cubed. 1 plus 6 would be 7a cubed. And you'll notice as I'm doing these, I'm drawing lines underneath them. When I have a long string, it just helps me keep track to draw lines under the like terms, just so I don't end up skipping one at the end. Now this one's going to be interesting because, see, we've got some clearing parentheses that we need to do. So this is coming back to our order of operations, our distributive property. We're combining a lot of things that we've learned from this chapter into one problem. So the first thing I need to do is clear parentheses before I can collect like terms. So you need to clear parentheses first, then combine like terms second. So if I hippity hoppity, I'm going to have 9 minus 5 times a positive 7x gives me negative 35x. A negative 5 times a positive 9 gives me negative 45. So now I have cleared the parentheses using the distributive property. Let's see what we can combine. I can do the 9 minus 45. And so they're opposite signs. So 45 minus 9 is going to give me 36, and it's negative because the 45 is bigger. So negative 36 minus 35x. I don't have anything to combine with the 35x. There's no other x's in my problem. All right, let's do one with clearing parentheses. When we get to equations in the next chapter, you're going to be doing a lot of clearing parentheses. So, I mean, we could talk about it now. I'm going to take 1/3 times both of these. I'm going to take 1/5 times both of those, and then we're going to combine like terms. So I'm going to write this one out because it's easier for you to see. 1/3 times 12 over 1x plus 1/3 times a 6 over 1. So those cancel. 1/3, that's going to be a 4x. 3 goes into 6 2 times, so plus 2. Minus, and I'm going to have a minus 1/5 times a 5x. Those are going to cancel, so I'm going to have negative 1x, and then I'm going to have negative 1/5 times a 2. So that's going to be negative 2/5. I can't cancel that one out. So when I combine like terms, 4x minus 1x gives me 3x. I'm going to come over here. I'm not going to work this one. I'm going to do these fractions. So I've got 2 over 1 minus 2 over 5. Okay, so common denominator would be 5. 1 times 5 is 5, 2 times 5 is 10. So 10 over 5 minus 2 over 5 gives me 8 over 5. So 3x minus 8 over 5. And that's probably the easiest way to work that one. I don't think you have any that difficult in homework as far as combining like terms and clearing parentheses. Most of them are going to be whole numbers, like this very next one. So I need to clear these parentheses, and then I'm going to combine like terms. So hippity hoppity, negative 2 times 5x gives me negative 10x. Negative 2 times a negative 8 gives me positive 16. Negative 3 times a positive 4 gives me negative 12. Negative 3 times a positive x gives me plus 3x. So then let's combine what we can. Negative 10x plus 3x gives me negative 7x. 10 minus 3 is 7. 10 is bigger, stays negative. 16 minus 12 gives me a positive 4. And I can't go any further than that. Okay, here's one that's got a lot of nesting with it. So it's got a lot of parentheses in with brackets. Let's go from the inside out. So negative 12x minus 2, not doing anything there, not doing anything with the 4x. I'm going to hippity-hoppity the negative 3. Negative 3 times x is negative 3x. Negative 3 times 5 is negative 15. Minus 9. Now, I knew to use distributive property on this one instead of order of operations because I have an x and a 5 in that parentheses. If I had had just straight numbers, we've done order of operation number problems before, I would have just gone straight to order of operations and done the parentheses. But since I have an x and a 5, they can't be combined. So I know I'm using distributive property. So if you see variables in your problem and you've got parentheses, you're going to distributive property. Alright, so let's continue. I've got the bracket in here, so I'm not doing anything with negative 12 minus 2, or negative 12x. I forgot to write down the x up there on that line. Okay, so I'm going to combine what in here. 4x minus 3x gives me a 1x minus a 15 minus the 9. Now I have a negative 2 in front of the bracket. I've got to hippity-hoppity that negative 2 through here. So I still have negative 12x. Nothing's happening with them yet. Negative 2 times x is negative 2x. Negative 2 times a negative 15 is a positive 30. That clears that parentheses or brackets in this case. Minus 9. Let's combine what we can combine. Negative 12x and another negative 2x. Add them and keep this negative sign. So that's negative 14x. 30 minus 9 is a positive 21. So negative 14x minus 21. Alright, here we go. Let's do one more of these. This is the last page. Let's just do one more. So again, it's brackets with parentheses combined. So I'm going to work inside out. So none of this is changing. I've got a negative 1 in front of this parentheses that I'm hippity-hopping. So that's going to change that to negative 5x and a negative 1. I can't combine anything in that bracket now. So I'm going out here to the 2 and hippity-hoppity in the 2. So 3y minus 2 times 4y would be minus 8y. Minus 2 times negative 5x would give me positive 10x. Minus 2 times a minus 1 gives me plus 2. The only thing I can combine are these y's. The 10x and the 2 are going to stay. So 3y minus 8y gives me negative 5y plus 10x plus 2. And that's as far as I can take it. I can't combine anything else because they're y's and x's. They don't match. So there's your properties of real numbers and simplifying expressions.